first order differential equations. They are equations which are generally written in the form dy dx is equals to f of xy, where f of xy is a function that depends on x and y. And first order differential equations are also differential equations where the highest derivative is 1. As in this case, you can see the highest derivative or the differential of this is 1. First order differential equations are also divided into different types. The types depend on the method in which the differential equation can be solved or evaluated. The first type is first order seperable differential equations. These are differential equations that can be solved by the method of separation of variables or grouping of the same variables together. These differential equations are generally of the form dy dx is equals to f of x times fy. For example, we have equations like dy dx equals to x over y into 1 plus y squared. You see, this equation can be separated in this form. You see, it's first order because the highest derivative here is 1, which is this one. Example, find the general solution of the differential equation y dy dx equals to x into 1 plus y squared. This is a first order differential equation since the highest derivative is 1. That's to find the general solution of this differential equation. We need to separate the variables of y from that of x. That's to do that if we multiply both sides of this equation by the x, that's dx here, we see this dx here is going to cancel this one, and I will be left here with y dy equals to x into 1 plus y squared dx. Now I want the y variables to be in one side of the equal sign, so if I divide both sides of this equation by 1 plus y squared and then I divide here by 1 plus y squared, this one will cancel here, and then I'll be left with y all over 1 plus y squared dy equals to x dx, since this one cancel this. Now, to find the general solution of this result, I need to integrate this side with respect to y, and then I also integrate this side with respect to x. If we look at this left hand side of the equal sign, we see that if I differentiate the denominator, I am going to have 2y. That means if I multiply the numerator by 2 and I multiply the denominator by 2, I have not changed the function since 2 can cancel 2. Now, if I factorize this 2 out of the integral sign, I'm going to have half the integral of 2y, since 2 times y is 2y all over 1 plus y squared dy equals to the integral of x dx. Now, why I'm multiplying the numerator by 2 and the denominator by 2 is to make sure that I should have 2y at the numerator. That is my target. Why am I doing so? There is a formula of integration which says that if there is a function f prime of x all over f of x, then the integration of this function with respect to x will be equals to the ln of f of x plus the constant of integration. And you see that when I differentiate the denominator, I'll have 2y. So it means the numerator here is the derivative of the function at the denominator. So it means the integration of this function will be half ln 1 plus y squared. And then for this right hand side, the integral of x is x to the 1 plus 1 all over 1 plus 1, which is the same like x squared all over 2. So it means the integral of x is x squared all over 2. This one is coming from the formula of integration, which says if I have y equals to x to the n, it means the integration of y, the x is the same like x to the n plus 1 all over n plus 1. So this one is plus the constant of integration. So this one gives the general solution of the differential equation.